A. So, sorry you were getting annoyed drawing the things. Which one? Right. So, modulus, just remember, we're just using Pythagoras' theorem to find the length. Are we happy with that? So, when we come to question 3, I just wanted to do it together because I do like them. What do these little doodads represent? So just, guys, just because you did it doesn't mean you can now chinwag. So would you like to come on down? Really, Eth? Come on. That means you're going to have to write big. I was going to say mystery, but I've just said Ethan, so people at home sort of know. And quite frankly, Moses, missing you, Iman, not the same without you. We'll talk to you in a minute. I'll do the first one. Can I do the first one? And then you can come on down. I think they're over there, mate. So that was masks, if you didn't know that. So let's just have a look at the first one. What is that saying when you read it? Now, what does the modulus, they said modulus of z equals, what does the modulus mean? The magnitude / the length. So we're saying that the length of the complex number is equal to 2. Now, that means it could be this one, couldn't it? And technically, it's actually that complex number there. Right? That dot. We represent a complex number with a vector, but the actual complex number is that spot. Okay? We sort of just get a little bit lax and we just always draw the line in, but it's technically the spot. All right? And so that one is also the complex number that has length of, magnitude of, d. And that one. And that one. My board's out of whack. I've got to rescale it. Anyone, any others? It's all the way around. That's right. So, oh no. Oh no. No. Disappointing. We're back to, oh, that's not too bad. So that one, obviously, is just a circle that is length 2. Does that make sense? Those are all, everything on here is the complex number that would have length 2. So, step on up. Mystery person. And, do you want to use the same one? Do you want to, shall we be tricky and change this to 2, just to save you? And so the diagram is big enough. And hang on, you get to do the fun. I'll give you, want 5 points or 25? 25. All right, and so, sorry, those at home, you don't get to watch it. No. Oh, yes, you're going to have to watch it. There you go. I don't know if this will work now. Uh-oh. Does that mean because I touched the board twice, it's those 2 points have gone down there? Rot roll. Rot roll. Rot roll, Scooby. Actually, that's Scooby saying it, so it's rot roll, Shaggy. It'll be interesting to see what happens to the board now. And Eden is being very funny at the back, so we'll just see what has she said. No, we're coming now. What were you laughing at?
Just the focus on him with the dot.
Focus, yes. So our mystery doing he's very focused, or she. Sorry for those playing at home, but I couldn't stop the recording. Good job. Oh, I think I might have stuffed it with that first one. Anyway, let's see. So let's go a different colour to be bold. There we go. Oh, yeah. Hang on. Oh, no. Oh, no, wait. Yeah, that's all right. Hang on. So sorry about that. We had to recalibrate several times. Not good enough for the master. Just go bold. Go bold. And I'm a bit concerned that no sound will come out. See up here, look at that. Ooh. Does that mean there's no sound? Oh well. Too bad. People won't mock me so much now at the board. Anyway, we get the gist. Right, so it's the inside. And that's beautiful, by the way, and it's because it's less than or equal to. If it was less than, which we're about to see in a momentito, what does that mean? Well, the thing around the outside will have to be dotted. It'll have to be a dotted line, okay? So I'll show off now on the next one. You stay here, though. I'm going to go, I think I'm feeling orange. Right, so we'll just change this. This is now going to be 4, -4, 4, -4. So what do we think this is saying? Right, it's in between. The length is in between 4 and 3. Now, because it's dotted, watch, because you're going to have to do the inside one, right? It's going to go. Not bad. Now hit 3. Oh, it's a bit, quadrant 1's a bit dodgy, isn't it? Never mind. I wouldn't have blamed. He's very good. Makes me lift my game. It's good. It's still out of whack, isn't it? That's good. That's good. Oh, that's bad. Correct. 1 ring to bind us all. No? Save them all. There you go. Okay, so now, are we getting the gist of this, peeps? So now, remember, what did arg mean? The angle, the argument, yep. So if it's saying it's between 0 and pi, what does that mean? Well done, labelling. Nice, nice. This is not me drawing, by the way. This is, well, it's Ethan, and he's doing a damn fine job. All right, so we'll leave these little ones for you to carry on with. Well done. Thank you. Round of applause, round of applause. Have a look, but I hope you get the gist of this is going to be in between the angles. Just find where they are. This is going to be a straight, bang, a length. So, 3, beautiful. Thanking you. Question 4, I think just suss it and what it's going to prove. Kelly can already tell us. What does question 4 do to us? Question 4, what will that prove to us? Well, have a look. It's the modulus of z, so the length of z, and what's the length of its conjugate? What could you expect even without doing it? They're going to be the same. That's right. And lo and behold, sorry if they're ruining the surprise for you, but that's one of our modulus properties here. So if you need more practice finding the length, going this squared plus that squared, all square rooted, if you need to do that, please do so. If you want to make sure that you can cube a complex number on your calculator, do so. I am now going to assume that you can do that beautifully. Did we do 5 and 6? Now, I'm going to be very nice today because I know you had your methods test yesterday. Oh, and today. Right. Oh. So, but I can't always accept, oh, no homework because I had this to do, because then I've got to study for methods, I've got to study for physics, I've got to study for, so you've got to make sure that you do keep up, and thank you for those who did do it. So I know you were looking forward to doing the induction. Maybe I'll do that Friday in our double. Is that our double? Because I do want to move it along a little bit. A lot of this is straightforward, I'd like to think. What? Oh, well, stop. Sorry. So it's a short lesson. We're gonna go full tote. Shh. So 8. Is this where we're carrying on with today? 8. I know. I said 20 an hour's worth. Keep going. 40 minutes. 40 to an hour. What a request for 6. I'm just talking to Dan at the front. I'm assuming you are okay with 6. Don't let me exclude you, though. If you wanted to play along, you sure can. So we'll say let Z1 be A plus BI. And, of course, Z2, we will make that be C plus DI. So we'll start with our left-hand side. And we've got, we want to find the conjugate of Z1 over Z2. So what I will actually do is I'm going to start by just finding Z1 over Z2. And then once I've got that, then I'll take the conjugate, but I don't want to have to keep writing. All right, so we've got A plus BI over C plus DI. I'm already groaning at this one, but what do we have to do to get rid of that imaginary from downstairs? Times by the conjugate, that's right. So we're going to multiply by C minus DI all over C minus DI. Sorry, Ethan, is that annoying you? I didn't go on the line there. Might have been a tad deliberate, but anyway. So AC minus ADI plus BCI. Positive times a negative. Remember the trick from last year? You go, that's minus, but B times D is BD, and I times I, negative 1, so change it to plus. All over C squared is difference of 2 squares. We know that's why we did it. Positive and a minus is a minus, and then it's D squared, but again you've got I squared, so it becomes plus. Huzzah, yes? That's right, that's right. So therefore, right, we're just going to group our terms there. So I've got AC plus BD, and I can say that's over C squared plus D squared. And I've got minus AD minus BC I all over C squared plus D squared, oui. Therefore, the modulus of Z1 over Z2 is going to be, yucko, that squared plus that squared. And remember, when you are taking the modulus, I'm not sure why, but a lot of us were doing this last year, when we were trying to find the length of something like 3 plus 2i, a lot of you were squaring the 2i. But when you're wanting to do this, that would, the modulus there, it's just the 3 squared plus the 2 squared, all rooted. Don't take the I into account. That's just telling you the variable that you are, the coefficient that you're using. So, I think you're going to go, rrr. So that squared plus that squared all rooted. I would then look at your right-hand side, play with that and see that they equal each other. It's going to be a bit ugly. Good luck. Yeah, I'm out. Back and look at the rules. Okay, so we're looking, don't worry about 7, we'll do that. I'm talking to the people who are at home now, Moses and Iman. Bobby, I forgot you. You're coming back tomorrow though, Bobs. I was just looking at Bobby there on the day map. Anyway, so we can split this up, okay? So this would be the modulus of 3, which we know is just, it's just 3, times the modulus of z, and the modulus of z is 2, so 3 2s, bang, it's 6. Right? This one, split it, it's going to be the modulus of 2, or minus 2, times the modulus of z. Once again, what is the modulus of minus 2? 2. So it's just going to be 2 times 2, so 4. So nothing really to see here. Ooh, split that into complex numbers. How are you going to get the modulus of a complex number? 2 take I. Well, we're all over this by now, aren't we? 2 squared plus 1 squared. I mean, you should be not even going minus 1 squared because we know the squared gets rid of that. So question 8, nice. Question 9, it's giving you the heads up. How do we get rid of the modulus? What makes them sort of disappear? If you square both sides, right? So have a look. We've squared both sides. But then we're in a little bit of a quandary. How do we get rid of this squared and the modulus there? What's going on there? Well, that is one of your rules, and I hope you are copying down. Okay, so our modulus squared equals the same, Eden, that's one you just proved, right, is that complex number z times its conjugate. So if we go back, this little system here, it's just the process going on. So we're going to say this will be z plus 1 times the conjugate of z plus 1, because we're using that property. Okie dokes. And we've got a second property here, right? The z plus w conjugate, we can put the conjugate to each one of those. So that becomes the conjugate of z. Conjugate of 1 is just 1, and so on and so forth. Then we expand as per normal, and lovingly things cancel. So everyone here, you would just follow blindly. It's very, very straightforward. See, that doesn't look like the example. What are you going to do? Use the rule. That's right. That says, right, modulus of z1 over z2, you can separate the modulus, and then it becomes like the example. So look, your time is precious. Do you want to do all 4? Do you want to just do 2? That's your call. Yeah? So give you 5, and then we're going to finish with polar form. So don't worry about 9. Kick it to 10. Polar form. It's just another way to write complex numbers, and it's going to allow you to do crazy things with those complex numbers. So you might want to take it to a power of 20, and you might be going, why would I want to do that? Well, a question might ask you to. Right, there are things that we do, and it just becomes a whole lot easier if we use polar form. You go, why is it so? So this is our polar form. And, you know, I will save this for you. You've got the video happening, so if you don't want to madly copy down, I'm not asking you to. So z equals the conjugate of z, so the length of that complex number, cis theta. What is cis theta? Well, I'm glad you asked. It is cos theta plus I sine. Look how clever. Look how clever those mathematicians are. So cos theta plus I sine theta. Be asked to have a complex number in this form, and you're going to be asked to put it into polar form, and of course you're going to be asked to go backwards. Your calculator will also do it for you. So in a moment, I hope you have your calculators with you. Do you? Oh, you good boy? You have yours? Bad boy. Oh, got a bad cough there, G. You all right? I'm negative. That's all right. That's all right. I'm more worried about you. It's all good. So, how does it come to be? Well, let's just think about it. And by the way, I just said that, yes, your calculator will be able to convert it backwards and forwards. Again, all we have to do is say do it algebraically. And we can do the sneaky little thing by just putting letters in there. We've already got I, but I could do the basic A plus BI. I think in your textbook they'll even fancy it up a bit with a K. But it all comes down to knowing our complex numbers. And this is our real, right? So here, would you agree, what would that value there, that length is how much? Yeah. So that whole length there is A, and this whole length here is going to be B. So your modulus of your complex number, the length, is clearly A squared plus B squared, all square rooted. We know all of that, yeah? But where is this cos theta plus sine theta coming from? Well, let's go back to right angle trigonometry. What is cos theta? Is it not adjacent over hypotenuse? So if this is my angle, what is my adjacent? A. So it's A over the hypotenuse, which is root. If you wouldn't waste your ink copying this down, unless you really want to, but again, I'll save it. So that's your cos theta, What is your sine theta? So B over, I'm already getting bored with this because now when we say, if you were to slap that into, right, cis theta, cos theta plus I sine theta, so this plus this with an I in front of it, and then you times it by the length, which is that, don't you get back to A plus BI? So it's just showing you that this form is going to be the same as, they are equivalent. Does that make sense? So instead of having to write cos theta plus sine theta, we just go cis and we put the angle that we would find here. Okay? So when we do it with real values, I'll stop because people did want to write actual numbers, all right? 1 plus root 3i, and we want to write that complex number in polar form. If we did it by hand, we do this. We go, okay, we got 1, we got root 3. What does that mean the length is, the hypotenuse? 2. Good. Right, root 3 squared is 3, plus 1 squared is 1, so that makes 4. Square root of 4 is 2. We're happy with that? But to write it in polar form cis theta, so at the moment what we have is our polar form is going to be 2 cis. What is our angle? How do we get this angle? I'm glad you asked. Well, how about we go, technically because they've given us the root 3 and the 1, we should use what they've given us, but because this is a lovely whole number and it's going to end up being my fave, my absolute favorite expression or statement, sine theta, right? No, it wasn't my favorite. Sine theta, it's my second favorite. Root 3 on 2, therefore, what is theta? Do you remember? I remember pi on 6. So sine of 30 is a half, which means sine of 60 is the other one, and 60 is pi on 3. So that means we've got, this is pi on 3. That in itself is nothing huge until we come up with this theorem called de Moivre's theorem, which is coming to a venue near you. Grab those calculators, please. Oh, so simple, it's going to be done well before my 25-minute mark. So we grab our calculators. We're in the run mode. The first thing we need to do is make sure that we are in radians. Bar, 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 bar. Bar. No, never gra. Don't think I've ever used gra. Would you be horrified to know that my year 11's methods, some of them have never or rarely picked up a graphics calculator? I was shocked. They should. Advanced maths, year 10, they should use them, yeah? I forced mine. You all right? Did you want to go and have a drink or something? You do what you need. Okay, so are we ready? Are we ready? All right, we go to option. Where do you think we're going to go? No! We're doing, what topic are we doing? Complex. Let's go complex. Nothing to see here, although, how insulting is that it will tell you what the conjugate is? In your free time, why don't you type in 2 plus I and then press your conjugate and see what it spits out? Scott, you absolute, you could try that. Anyway, we're going to go to more. So F6. Look at this, even if you weren't quite sure. Can you see these 2 buttons here? And again, these are damn insulting. What do you think that is for? The real part? And the imaginary part, I can't say I've ever pushed that. I am tempted to go, if I put in bracket 2 plus I, real, will it tell me it's 2? I don't know. But anyway, it's this one. It's this one that's really cute that we are going to use. Now, to use it, we are going to put our complex number in first. So what was our complex number? 1 plus, we do have to put the I in. So shift I. I can't remember. Will it be helpful to just say root 3, or do you have to put the times root 3? I'm just being precious and I'm putting that in. And then we just press it and enter. Who got syntax? Now, you will also have the situation where you will have polar form and you want to get the non-Cartesian form, and bang, you can just go there. There is also this one on our calculator. That's a shortcut, but we'll play around with that a little bit later. So you can see it's pretty simple. It's just a little bit of right angle trig that we're playing with to find the polar form of these things. Now, one catch, I mean, you can try this. Look, it's got the K's. So you're doing, I don't want you to do too much there, but have a think, one thing is the angle that we're dealing with. It has to go between minus pi and pi. So there will be no 2 pi. There will be no 3 pi on 2, right? So 3 pi on 2 will be minus pi on 2. So don't worry too much about that. That'll come in a little bit later. They're asking you, we've just had a look, show you a calculator. So I would really like it if you could sort of get up to, it's not asking too much, I don't think, maybe up to 7. So do the, again, if you went on, I'm not going to stop you, but we'll just do up to 7. Is that okay? Do I need to do another one in the next minute? Right? And think about, do I even need a calculator to work out the polar form of things like 4, 4i, and minus 6? Because what I want you to do is I want you to think about where they sit on your argand. So, where is 4? Now, is that going to have something there? It's just, well, that's just 4, right? So, because it's got no angle. And what's cis of 0? Well, that's technically cos of 0. And what's cos of 0? 1. And what's sine of 0? 0. So 4 will just be 4. So that was a stupid question for them to start off with, right? Bit mean. What about 4i? God, it sounded very Aussie then. 4i. I. Right? Your imaginary is up here. Don't mock my eye. That's 4. So what is my angle? Pi on 2. So I don't need any calculator. I don't need any trig there, right? Because 4i will just be, what is the length? It's going to be 4. And what is my angle? Cis pi on 2, right? So sometimes those easy ones are actually the ones that we go, it doesn't work. So think about now minus 6, any takers? What would minus 6 look like? Out here, what's the angle? Say it properly. Poi. Poi. Meet poi. And again, it's not going to be minus 6, sis. It's just 6, and you get the gist. Is that all right? If you run out of time, and yes, I know some of you have got your test on Friday, so try and squeeze in 40 minutes for me. Up to 7. Uh-oh, I've lost my... I can't stop the record. Oh, there it is.